Hello, this is Mesos Orm, and welcome to Understanding S.F.M.L. Today, we'll be learning about vectors. The inputs for vectors must be the same type as the vector themselves. Here we have a vector 2f, which deals with floats, and these inputs must be floats themselves. At start, input values may be declared next to the variable name in parentheses. Input values may also be put inside of curly brackets before setting the vector equal to them. Finally, input values may be cast in the same typing as the variable before setting it equal to it. This method can only be done at declaration, while these two can be done at any time. A vector 2i can work with any signed int value, so it can work with any negative or positive int value, while a vector 2u can only work with the positives. A vector 3f is the same as a vector 2f, except it can work with 3 values instead of 2. And a vector 3i is the same as that, except with the vector 2i. Now I'm going to delete these as we don't need them for the future examples. For the vector function angle, we will get an angle from the x-axis. Just remember that all angles that we get will be upside down from what we would get if we would graph them. So if we were to say this is the x-axis and we were to get 90 degrees, instead of it being up here, it would be down here. Now if we open the debug menu, we can get the angle, and we can see that it's about 2.4 radians. If we were to say as degrees, we would get, let's see, 137.508 degrees. Though most of the time in programming we won't want to work with degrees but radians. For the function angle2, we will get the difference in angles of our second vector from our first vector. So here we would say v1 angle minus v0 angle. And we could check that out in the debug menu. And we can say it's about negative 1.3 radians. For the vector function cross, we will get what's called a cross product. This will be the area of the parallelogram between the two vectors. As a bonus, it will give you an idea of the rotation direction, as positive values mean counterclockwise and negative values mean clockwise. Here, if the value is negative, the angle of v0 would be counterclockwise of v1. Otherwise, it would be clockwise. Now we can enter the debug menu and see that it would be counterclockwise. For the vector function dot, we will get what's called the dot product, which is how much two vectors are pointing in the same direction. If the vectors are facing in the same direction, the dot product will become positive. If one of the vectors is perpendicular to the other, the dot product will become 0. And as they head towards opposite directions, then the dot product will be negative. We can open the debug menu and see how close these are facing towards each other, and since they are very close to 1, they are very close to facing towards each other. The vector function length will just give you the Euclidean distance from 0, 0, or the origin. And we can open the debug menu and see about how far away we are, and we're about 2 units. Length squared will give you the same thing, but it will just square the length. We can open the debug menu and see that. It'll be about 3.9999, almost 4. The vector function normalized will make this vector into a unit vector, which means it will basically make it fit into a unit circle. In other words, if it was on the origin, it would have a length of 1. Now we can open the debug menu and see what that looks like. Now we can see that the vector has changed in size into a unit vector. For the vector function projected onto, if we were to take the end of the shadow cast from this vector onto this vector, that's what we would get out and put onto this vector. If we were to open the debug menu, we can see that the shadow is cast at these coordinates. For the vector function perpendicular, we're turning the vector 90 degrees and setting it as that. We can open the debug menu and see that. You can see that it's turned 90 degrees. For the vector function rotated by, we are rotating about the origin by however many radians or degrees that we input here. We can enter the debug menu and see that we have rotated quite a bit. Component-wise multiply will take the x parts of our v0 and multiply it by the x parts of v1, and the y parts of v0 and multiply by the y parts of v1. We can enter the debug menu and see that we get that output correctly. Likewise, with component-wise divide, we are taking the components of v0 and dividing them by the components of v1. Let's open the debug menu one last time and see that we are dividing each one individually. Now that's it for vectors. Thank you for joining me today. If you did, then please like, comment, and subscribe, and have a great day.